Good afternoon. My name is F.Duarte, my partner is J.Fassi. And for our paper presentation, we are going to expose and explain Harry Markowitz's paper named Portfolio Selection, which was written by 1952. The content of this presentation is divided into 5 parts. First, we are going to explain briefly the process of selecting a portfolio. Then we are going to contrast two hypotheses on investment behavior. After that, my partner is going to show a geometrical derivation of 3 security case portfolio. Then we are going to emphasize how the investment behavior is different from speculative behavior. And finally, we highlight some consideration and warning that must be taken for a proper portfolio selection. The selecting a portfolio process may be divided into 2 stages. The first stage start with observation and experience and end with belief and future performance. Here, we obtain returns, variance, and covariance. All that information we use in the second stage. The second stage start with belief and future performance and end with choice of portfolio. Previously to 1952, the rule to guide investment behavior was typically to maximize discount expect return. This rule can be found in the 1938 by G.B. Williams paper named The Theory on Investment Value. So, this rule can be rejected. Why? Because it never implies that a diversified portfolio is better than a non-diversified portfolio. To see, consider the following. Given the goal of maximizing spread return of our portfolio, which is defined as the composition of the I security times its spread return. Now this is subject to as the composition of all x sub I sum to 1 and not allowing yourselves. Then we obtain this. This is the max of spread return. And then the goal is suffered with any combination of this subset, subject to, or this composed for all security with max spread return. Therefore, a non-diversified portfolio is equally preferable to a diversified portfolio. Why the previous rule has been proposed and used? The main reason was the application of the law of large number, which will ensure that the actual yield of a portfolio will be almost the same as the expected yield. But, however, this presumption cannot be accepted because the return from security are too intercorrelated, and the diversification cannot eliminate all variance. So instead, Markowitz proposed a quite intuitive and simple rule that considers that the spread return as a desirable thing and the variance of return as undesirable thing. In this day, that rule is known as EV rule. Doing this, we end up with an efficient frontier of combination from a set of attainable combinations. For example, a portfolio in this place is dominated by a portfolio in this place. Now my partner.
Now I will continue and I will try to show you a geometrical derivation of a 3 security case portfolio. Before to do that, we have to make some assumptions. First, the PDF of the yields of various securities is not a function of time, because that assures us that the portfolio that's made is constant. If not, time t10, we might want to change the composition of portfolio. Second, the portfolio is composed by all 3 securities, and because the composition of one security is the complement of the other 2 ones, we can reduce this to a geometrical analysis in a plane. And third, the short sales are not allowed, so we can focus in a defined restricted solution space. So given that, we can reduce our model to XA and XB plane, where we have that the expected return that is equal behaves as lines, as straight lines. Okay? So given a value for the expected return, we have a line which is a linear combination between X of A and X of B. And for the variance, we have that they behave as concentric ellipses. We do the math, and we fail, but we arrive to this kind of equation with if h squared is less or equal than A times B, this is an ellipsis. Okay, so given that, and that is not allowed short sale, so all must be positive, we have this. Okay, these lines over here are the expected return, equal expected return for a portfolio. And these ellipses are equal risk or equal variance. So, to find an efficient portfolio, we have to find the tangent line or the tangent expected return for a given level of risk. And this gives us this quite a bold line. So, we found this portfolio named X, which is the minimum variance portfolio, and we move in a tangent line of ellipses to the expected return until we match the condition that short sales are not allowed. And then we down in this line to the optimum, given that X sub B, for example, in this case, has a greater expected return than the other one, X2, in this example. Now, Markowitz rule is a pretty good explanation both for investment behavior as a hypothesis, which we are going to see later, and as a maximum guide to invest in reality. So, he says, the rule serves better as an explanation of investment distinguished from speculative behavior, and I want to highlight that. And on the other hand, we have that this not only implies diversification, but implies the right kind of diversification for the right reason. Why? Because it doesn't depend solely in what we might think, have a portfolio which has many securities. No. You must have a portfolio of many securities from different industries and try to find securities that are not highly correlated between them. Okay? So take for instance, we have portfolio say P prime, which is this one, and P double prime, this one. They both have the same variance, same risk. So if I made a linear combination of this portfolio, say we have portfolio P, which I use a lambda, which is a number between 0 and 1, we might end up with a portfolio in this line, which in any case, except the extreme cases, we have a portfolio with less risk. And the expected return will be less or greater. That depends. The thing is that we can diversify between two assets. Okay? Now, I want to contrast speculative behavior with investment behavior. Investment behavior can be represented mathematically with a function, utility function that depends on expected return and variance, which is a measure of risk. So for this guy, the expected return, if it's greater, the utility function will be greater. And on the other hand, if the risk is greater, utility will be less. But this guy, which follows an investment behavior, won't accept any actually fair bet. Okay? And on the other hand, if we have a guy that utility functions depends on the third statistical moment, which is bias, it might accept fair bets. So this is a mathematical opposition between investment behavior and speculative behavior. And finally, some considerations. The expected return and value rule is reasonable for a variety of investment institutions, which considers this quite simple: yield, a good thing; risk, bad; and gambling, to be avoided. And is useful both, as I said earlier, as a hypothesis and on investment behavior, and as a maxim to guide investment. So in both cases, as something that we can use to study things, and something that we can use in reality, the EV rule is a good approach. And finally, some important warnings. The most valuable aspect within the EV rule is to find reasonable estimation of expected return and covariances, which may abstain from statistical procedures and the judgment of the practical man. And finally, we must study in more detail the first stage of a portfolio selection, which is the formation of relevant beliefs on the basis of a theory. Thanks for your attention. If you have any questions?
Yes, so they are technical ones. I was going to ask you if you did the diagnosis test,
If we
the placement test,
which one?
the English one.
Yeah.
Yeah. Did you remember what was your result?
The test that we do for this activity, or
Yeah.
the test that we do in English 6 when we...
No, for this activity.
I obtained B2.
Perfect. You are full, right?
B1.
Pass, yeah.
B2 and you B1. Perfect. That's it. Thank you.
What was it?
Too lazy for me.
Yeah, I know you will say that. We chose this classical speaker, but I really like to see an idea which is quite important as Markowitz portfolio selection to this original paper. Yeah. So, well, thank you for your attention.
Can you leave for a minute?
Yeah, perfect.